Hello everyone, welcome back to my YouTube channel Let's Code for Fun. And today we are going to see a very interesting problem statement, and we will try to prove this. Yes, let's get started. So let's try to understand the problem statement first of all. So it says that we are given this array A. Let's say for now we consider it to be having only odd number of elements. You can actually prove this for even numbers, and I will leave it as a homework. So let's say we have an element. We have an array with odd number of elements, and we have A1, A2, A3, A4, A5, and then we need to choose a number x, any integer, or let's say any number x on the number line, such that my s is minimized. Okay, now let's see what is x is. So this x is nothing but x minus A1 plus x minus modulus of, this is important, like modulus of x minus A1 plus modulus of x minus A2, and similarly, and summation of all of them. So what we do is we take x on the number line, we choose x to be any integer on the number line, and then we take the modular difference with this, the first number, then we add it to the modulus difference with the of x with the second number, and similarly, and go on until we reach the last number. And we need to choose x in such a way that this whole term, this s, is minimized. Okay, so So how can we do this? In fact, there are like so many numbers. There are infinite number of numbers on the number line. We would run out of time, right? So I will claim something and then I will prove it. So I will claim that if we choose x to be the median of this array, then we are sure, we are 100% sure that this s is minimized. We cannot get a sum smaller than s if x is the median. Okay, so we will try to prove this. So let's first of all write our claim. So our claim is that if x equals median of the array A, then s is minimized. Okay, okay. So okay, I will first again revise what is the median. So median of an array is, let's say if an array A is given, you sort it in ascending order, and then you choose the middle element for, which is why I said initially that we will choose just the element with odd numbers for now. For even numbers, you can do it by yourself. So here we can assume that this array A is sorted, and then we will choose A3 to be our uh, median. Okay, so let's prove this. So let's draw the number line first of all, and then we'll place all the numbers. Yes, I have ample space. So, so we have number line, and let's say these are our numbers: A1, A2, A3, sorry, A3, A4, and let's say A5. Okay. Now let's try to write S when when x is equal to A3. So x is equal to A3. So can we say that in this case, so this is a number line, right? So we can say that this is x. So can we say that the first term, that is modulus of x minus a1, will be equal to this distance, right? D1. We can say that, right? I This will be equal to D1. Similarly, okay, this is not. It is will be equal to A2. Similarly, can we say that the second term, uh, x minus A2, this will be equal to this term, this distance, D2, right? We can say it, right? Similarly, D3 will be equal to 0 because x is equal to A3. So we will leave that. Next, we'll move to A4. So we can say that this distance will be equal to D4 and this distance will be equal to D5, right? So instead of writing it like x1 mod of x minus a1, we can just write it like this, equal to d1 plus d2 plus d3, and d3 will be equal to 0 actually, plus d4 plus d5, right? So this is actually, this distance is actually the absolute distance, right? Absolute difference. So d1 plus d2 plus d4 plus d5. Okay. So now, okay, I should have, okay, wait, let's move this a little down. And yes, now, now let's say that we choose another number on this number line. Let's say that we choose another number x dash, and that x dash is a number which is a little less than x. Let's say it is here, and we can say that this number is x dash is equal to x minus h, and this h is very very small, like let's say 0.001 or any very very small number. So let's place this number h, and one second. So this is my number x dash. Sorry. So now that we are at it, let's me try to remove this and write it properly. Okay. So we can say, now let's try to do that distance thing again. So what is the what is the sum of like a distance from a1 to x dash? We can say that this is d1 dash. Similarly, with d2, we can say it is d2 dash. With a3, we can say it is d3 dash. Notice that here the d3 is not 0, right? Because we have certain distance with a3. Now, distance with a4 will be d4 dash, and distance from x dash till x5 will be d5 dash. Okay. So now can we say that, hmm, let me write this down. F of x equal to x minus h, x dash equal to x minus h will be equal to d1 dash plus d2 dash plus d3 dash plus d4 dash plus d5 dash. We can write it, right? So, so now let's try to find out the relationship between d1 dash and d1. So we can say that this d1 dash, as you can see, d1 dash is d1 dash is d1 d1 minus h, right? So this number plus this number plus this number is equal to d1. So we can say that this d1 dash is equal to d1 minus, okay. So once again, so we can say that d1 dash is equal to d1 minus h. We can say it, right. Similarly, we can say that d2 dash is d2 minus h, right? But okay, now let's write it down. We can say d1 minus h plus d2 minus h. Okay. Now mm, can we say that d4 will be equal to d4 dash will be equal to d4 plus h? We can say it, right. And can we say that d 5 dash will be equal to D5 plus H, right? We can say it, right? So let's try to write plus D3 dash plus D4 plus H plus D5 plus H. So we see that, and okay, now let's try to cancel this. So this H and H will be cancelled by this H and H, and this D3 dash gets unaffected. So, okay, now let's write it like this. D1 plus D2 plus D4 plus D5 plus D3 dash. Okay, so we can say that S of, this is S dash is equal to, so what is this term? This term is nothing but S, right? So we can say that this S dash is equal to S plus D3 dash. And what is D3 dash? D3 dash is nothing but H itself, this distance, right? So we can say that this is equal to S plus H. So we kind of proved it that if we take any number S dash, sorry, X dash, which is not equal to the median of the array, then this term S dash will be more than S, right? So you can actually do it for the number greater than uh, A3 also. And you can in fact pick up any number on the number line and prove the same thing. And you will find out that it will be greater than our original S that we calculated. And another homework which I'm giving you is that you need to do the same thing for an array which has even number of elements. Okay. So yeah, I hope this was helpful to you guys in some ways and you got to know how to prove this. Okay, anyway, I will upload this in some time. So goodbye, take care.